In this video, I'd like to give you some guidance on this normal distribution part 2 activity. In this activity, we will be using the charts that give us the data on pages 798 and 799 of the electronic textbook. You may want to refer to those charts. I'll show the charts here in the video, but you may want to have easy reference to those as we go. Here's the directions for this activity. Show your work and answer on a separate page. Box or highlight your answer. Skip a line before you start the next question. What I'll ask you to do is submit 2 things on Blackboard. You'll need to type in your answers. That's one part. And the other thing you'll need to do is you'll need to scan and submit your written work for this set of problems. And each one of the problems should have a sketch that's shaded and an answer that has a box drawn around it. Here's how you could approach the first 2 questions. What percentage of the data in a normal distribution falls below the mean? Number 1, what percentage of the data in a normal distribution falls below the mean? I've highlighted the area of the curve that's below or to the left of the mean, and we can see that that is 50%. For number 2, what percentage of the data in a normal distribution falls above the mean? I can see that that's also 50%. So on my paper, I'm going to have the problem written, the question, and the answer, and a sketch. There's really not work to show for number 1 or for number 2, but other than making sure that you have that sketch. Notice that the directions are going to ask you to give an answer that is a percent rounded to the nearest hundredth of a percent. These 2 are both just 50%. There's no rounding needed. Number 2 and 3, or rather 3 and 4, are questioning whether you understand what a normal distribution means. So here we have 1 standard deviation away, 2 standard deviations away, 3, 4, and 5 standard deviations would cover this much area. And what number 3 is asking us is what percent of the data is more than 5 standard deviations from the mean. And we know that 3 standard deviations came to 100% minus 99.7%. So that was just 0.3%, or approximately 1/3%. This is what we know from the empirical rule for standard deviations. That's 3 standard deviations. If we're talking 5 standard deviations, we're way out here, just tiny, tiny sliver on both sides. And it comes up so small that it's going to be 0%. We consider it to be 0% just because it's so small. Anything greater than 4 standard deviations, anything greater than 4 standard deviations is considered to be so small that we would call it 0%. Number 4 is almost like an opposite to number 3. Less than 7 standard deviations, now we're even further out. So that tiny, tiny tips off to the sides are still going to be considered 0. So less than that would be everything that I have shaded pink here, and we could call that 100%. We can call it or consider it to be 100% just because it's so large, so close to 100%. Let's look at the next set of problems, numbers 5 through 12. Numbers 5 through 12 are going to require us to use the charts. And these charts are in the e-text, page 798 and 799. You can find these charts elsewhere as well, but the copy we have easy access to is in this e-text. And here's how you read the chart. If I'm looking for the area to the left of z, when z is 1.30, the area to the left of z, I'm going to find 1.3 on the left, and then across the top I'm going to find the 0.0, and you can see that that leads me to this 90.32%, or the decimal is 0.9032. This first start, I'm just wanting to show you how to use this chart. What that number 0.9032 means is that the area to the left of z equals 130 will take up 90.32% of the curve, of the area under the curve, or 0.9032 is a decimal. So 90.32%, or as a decimal, 0.9032. That's what this chart means. If I find the score for z equal to 130, the score for z equals 130, oh, it looks like I skipped that one. Or let me make sure. 130 was here. So now I'm doing 170. Apologize for that. The z score of 1.70 gives us a percent of 0.9, or a decimal of 0.9554, which is as a percent is 95.54%. Let's make sure everyone can read this chart. I'm looking for the area to the left of 1.70, and that's where I get this 0.9554. That's how you read this chart. And what that's representing is this area to the left of z equals 1.70. What I'm doing now is just working through this chart for each question. So if I'm looking for how to use a chart for z equals 2.37, I find the 2.3 on the left and 0.07 across the top, and see that where they meet up gives me 0.9911. And one more, I'm going to use this table to find the decimal that represents the area to the left of z when z is negative 1.72. Make sure you're on the table that's negatives, and I can find the 1.7 to the left and the 0.02 at the top, and they match up to this decimal score of 0.0427. Now let's look at how to answer question number 5. Question number 5 is asking us to find that area between the z-score of 1.30 and the z-score of 1.70. Now, to be able to do this, I've got to understand what those values are representing. So when I have 1.7, remember from the previous screen that was giving us this percent, the 9554. And then when I found a z-score, the area for a z-score of 1.3, I got 0.9032. And do you see that what I would need to do, if I drew those together, if I put my 1.3 here, so I'm transposing my purple onto that green, do you see that what I'm trying to find is this area between them? So that's the difference, and that's why I'm going to subtract. When I subtract the decimals, I get 0.0522, and converting that to a percent, rounded to the nearest hundredth, it's 5.22%. For number 6, to the left of 2.37, You can see this in the diagram here at the top. To the left of 2.37, that's all I have to do is read that number from the chart, because if you recall, the chart is giving us the area to the left of our z-score. For number 7, when I'm looking for the area to the right of this given z-score, that's the yellow area. That's this. I'm going to draw the red lines through it. The yellow with red stripes. But the chart gives me this pink stuff over here. It's highlighted pink, right? Do you see that what I'm going to do to find the area to the right, to find that, this piece over here, it's yellow highlighted with red stripes, I'm going to subtract the 0.0427 from the chart, subtract that from 1 whole, and I'd get 0.9573. I can convert that to a percent by moving the decimal 2 to the right or by multiplying by 100, and I'd get 95.73%, or 95 and 73/100%. Less than z equals negative 0.45. That's a nice straightforward, pull it right from the chart. But number 9, greater than a z-score, I've got to, again, subtract from 1, because I'm going for this area that's shaded yellow. So I'm going to get that yellow area, I'm going to take the 1 whole and subtract the pink highlight. And then when I convert that to a percent, be sure you're only multiplying by 100. So it's less than 1%, 0.39%. Don't confuse that with 39%. For 10, 11, and 12, I've already collected the z-score values from the chart. You can see the values from the chart written in pink here. Make sure, don't just copy those numbers, make sure you can get those numbers from the chart also. But let's look at how we would use those numbers. If I'm trying to find the area between a z-score of negative 2.29 and negative 1.33, that's this area that's highlighted pink. Do you see that I'll have to take the score for the negative 1.33, 0.0918, and then I'll need to subtract this score for the 2.29, the 0.110. And then once I get that difference, I can change it to a percent. For number 11, I'll have to subtract again, because again, if I'm looking for the area between these two, I would first find this green striped area, and then I'm going to subtract out this purple striped area, and I'd be left with the pink highlight. So we'd subtract again. Number 12, subtract one more time. Do you see why you subtract though? For this z-score of 3.21, when I read that from the chart, what the chart is telling me is that 99.93% of the data falls to the left of 3.21. And the 0.34% of the data falls to the left of negative 2.71. So if I'm looking for what's between those two, I'm going to have to subtract. So to get this area between, I'll start with the 99.93%, and then I'm going to subtract the 0.34%. So I'll subtract again for between. Have you noticed that for between, we're nearly always going to subtract? Let's look next at how to calculate z-scores. We're going to use this formula. The data, that's the x, minus the mean divided by the standard deviation. So if x is 190, I'll subtract the mean of 250 and divide by the standard deviation of 48. I could then say that z sub 190, do you see how I write that? Z and then a subscripted 190. Z sub 190 equals 190 minus 250 divided by 48. We could find Z202 in the same way. Subtract the mean, divide by the standard deviation. Z sub 346 is a z-score when the piece of data is equal to 346. So 346 minus the mean of 250 divided by 48. Once I have those z-scores, I can answer these questions with a purple star. What percent of data is less than 190? If our mean is 250, then our data where x is 190 is going to fall right here. And if we're looking for the percent of data that's less than 190, we simply need to use the chart when z equals 125. If I want to find the data between 202 and 346, then I could see that the mean is here at, it's given as 250, and I'm going from 202 over here up to 346 over here, and so I want this area between. So I could use a z-score of 2 and oh, you know what? I think I left off the negative here, correct? A z-score of negative of 2 and then the z-score for negative 1. Find the values on the chart for each of those, subtract them, and that'll give us this area between. Well, I hope that this video is helpful to you as you complete this activity, but if you do have further questions or need further assistance, please don't hesitate to contact me. I'm here to help you with this activity or with other examples.